Alright, first thing we're going to do is start factoring. And right under here, I'm going to make my factoring box, of course. Alright, so as far as possible rational zeros go, this one is actually pretty easy because there's a 1 in front and there's a 9 here. So it's all the factors of 9 over the factors of 1. So all the factors of 9 are 1, 3, and 9 over factors of 1. So the only options we have are 1 over 1, which is 1, 3 over 1, which is 3, and 9 over 1, which is 9. And all of these can be plus or minus. So I'm just going to put a plus or minus out in front. Okay, so I'm going to start my synthetic division. Let's do it over here. And I have 1, 6, 8, negative 6, and negative 9. And I'm going to put my 1 out in front. I'm going to try that one first. If that doesn't work, I'm going to try negative 1. All right, first one, drop it down. 1 times 1 is 1. 6 plus 1 is 7. 1 times 7 is 7. Add straight down, you get 15. And 1 times 15 is 15. And let's see here, we get a 9. Oh, and this one works. And 1 times 9 is 9. Add them up, you get a 0. And that's going to be our remainder. And then this is going to be our other. So this is going to be the remainder, our c, x, x squared, and x cubed. Since this is a 1, the factor that is associated with a plus 1 is a factor of x minus 1. Okay, and then we have x squared plus 7x, oh that's x cubed, plus 7x squared plus 15x plus 9. All right, and then you bring this one down. This one always comes down. It's a factor. Bring it down. And then I'm going to factor this, and I'm going to get a single factor out of that, and then something here, it will definitely have a quadratic. This is going to be an x. This is going to be a quadratic, so that part should be easy to factor. All right, I'm just setting this up. I know what it's going to look like. There we go. All right. Well, now that I have this, now that 1 went in, I'm actually going to try again. Now, I can tell that it's not going to go in, but since 1 went in the first time, I'm going to do it again. So 1 times 1 is 1. We get an 8. We get an 8. Because these are all positive, notice that this is just going to start going crazy here. Now I'm looking for a 0 here. What do we got? 32. So that didn't work. Well, that didn't work. Then we rewrite this. 1, the 7, the 15, the 9. And then let's go in with a negative 1. Drop it down. Negative 1 times 1 is negative 1. Add, you get a 6. Multiply to this. Get a negative 6. This looks like it's going to work then. And then 9. And then negative 1 times 9 is negative 9. That gives us our 0. And that's our remainder. And again, this is our remainder, c, our x squared. So now that we got a 0 of negative 1, the factor that is associated with that is a plus 1, x plus 1. And then the other factor is right here, 1x squared plus 6x plus 9. And again, we're going to bring all these other ones down. You can't forget them. And then we're going to factor this. And because it's a quadratic, we don't have to go through all this process again. We factor it normally, and it looks like we get an x plus 3, and I forgot to bring this one down, and it's a plus. Okay, as far as end behavior, this is an even degree polynomial. The highest degree is a 4, so that's even. So it's going to be one of the first two, and since the number out in front is a positive, the end behavior is going to be this one. So it's going to be up here and up here somewhere. Okay, I'm not necessarily going to go through those x's. I'm just writing down where I think they're going to be. All right, so the zeros, now if you remember, if you already took the quiz, started already, you notice that there's lines here for you to put each one on. I only have one line, so I'm just going to put them here so I have room. So the first one is a plus 1, which we found here. Get rid of 1, and it has a multiplicity of 1. This one gives us the negative 1, and it has a multiplicity of 1. And then this one, if you set it equal to 0, right, it gives us a negative 3. And because there are two factors right here, 1, 2, it has a multiplicity of 2. And if you add those up, 1, 2, 3, 4, gives us a 4, which matches this. Don't do anything if that doesn't match. If those don't match, it means you did something wrong, and you have to go back and fix it. All right, so at this point, let's start plotting some of these points. All right, so we have a 1, which is right here, and a negative 1, and a negative 3. Now, because this is a 1, of course, this one is a pass, passes through. This one is a pass, and because this is a double root right here, that's a multiplicity of 2, that it is going to cause a bounce. Now, so right now what we have is it's going to come down, and it's going to hit the negative 3 and bounce back up. So I know it's going to come down somehow, and it's going to bounce. So now one of our additional points, let's start making that, besides the y-intercept, of course, which is 0 something, is we're going to put in a negative 2, because that's between these two zeros. This is a 0 of negative 3 right here. This is a 0 of negative 1. I have to pick something in between, and the easiest number to pick, of course, is that negative 2. So I would expect a positive value out of that, because if it comes down and bounces up, this value is going to have to be positive, or we made a mistake somewhere, either with that, or maybe there's a mistake with the zeros. I don't know. So it's going to come up, it's going to come back down, it's going to hit negative 1, and then because it says here it's going to pass through, it's going to pass through somehow, and then it's going to come down, which means we should have a negative y-intercept. And let's do that quickly. If you plug in a 0 everywhere into the original function, this will be 0, this ends up being 0, that 0's out, and that 0's out, leaving negative 9 as the y-intercept. So that's 0, negative 9. Let's write that down properly. And we're going to come down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's put a dot down there. And see, everything agrees. It sounds like it's coming down, back up, and down. And then it's going to come through here. It's going to come up through here, and then keep on going. So everything, to me so far, makes sense. Even though there could be a mistake somewhere, all the numbers I got make sense. Nothing contradicts anything. So I'm fairly happy with how things are going so far. So I think really the only thing we need to do is find this f of negative 2 for our additional point, and we're done. And then if you recall, if you go back to the original equation, especially with a number like negative 2, we don't have a decimal or anything. I think the easiest thing to do is just put that number in synthetically, and then the remainder is going to be our f of negative 2. So this is what we're looking for. Remember, find f of negative 2. If you want to plug negative 2 in everywhere there, go ahead. Go for it. I'm going to do it synthetically. Okay, drop it down. Negative 2, 4. Negative 8, 0, 0. Negative 6, 12, 3. Okay, good. If you remember from a few minutes ago that I talked about how this number better be a positive number because it's up here, so I found a 3. So we're going to put a 3 right there. And again, if you feel like plugging it into the original or anywhere else, you can plug in anywhere you want. It will give you that value. So we go 1, 2, 3. Pop it in right there. And we have everything we need. We're ready to graph. And I'm graphing on this little tablet thing, and I know these graphs are probably going to look all wiggly and awful, but I'm going to do the best I can with what I have. Okay, fairly vertical. Don't head over here. They're never going to do that. We're going to come down. We're going to bounce like we found right here. All right, we're going to come up. We're going to make it look very curvy. We're going to come back down through. Now this is a little hard because it's kind of a long shot down here. Start heading down here. We're going to curve up. And notice the steepness that I have to hit this point with from here. This is way down here. This is way up here. Just keep that steepness going. Don't just shoot off over here somewhere, because that's not going to happen. There's no abrupt changes except for like at the maxes and mins. There's abrupt changes, but on the ends like this, there's never abrupt changes. It's just going to kind of keep going. It's not going to go straight up and down, because then it wouldn't be a function. And something like that. And for the tools we have so far, that's actually pretty good. And again, we would be able to use the calculus to get a slightly better looking graph. And if there's a part of this graph that you don't like, it doesn't seem quite right, plug in more points down here. Find some more points that you like somewhere where you think there's an issue and plug in more. If you have to plug in -1.5, which is here, you'll get a point around here somewhere. If you want to plug in -2.5, hopefully you'll get a point around here somewhere. And that would help you create a better graph. But for now, with the points we have, that one's pretty good. Let's move on to another problem. All right, one thing to note, I added a little -4x squared right here to make this one a little easier. All right, let's make a little factor box. All right. So the first thing I see is that each of these terms has an x. Now, I didn't talk about it on the last problem, but we have to GCF every single one of these before you do anything else. Now, I'm looking for a number. Now, there's a 1 out here, so there's no number that goes into all of this. Like I'm looking at the 1, the 3, and the -4. But if you look at the x's, this has 4 x's, so x to the 4th. This has an x cubed, and this has x squared. So the most number of x's that I can pull out of there, and I have to pull the same number out of each pile, is an x squared. So I'm going to GCF the x squared in front there. And then we're left here with an x to this, let's see, x squared plus 3x. And then this one is just left with the -4. All right, then this x squared is going to follow us down the whole way, so we don't get rid of it. And then look what's left here. What we have left is a quadratic. So we don't even have to, solve or factor this using our P's and Q's and synthetic division and all that. This is a quadratic. We can factor this straight away without doing anything fancy with that other stuff. All right, so we have an x here and here. The -4 tells us that one of these is going to be positive, one is negative, and I need two numbers that multiply to 4 and add to 3, so that's going to be, this one is going to be a 4 here, and a -1 right there. All right, so each of these is going to give us some zeros. Now, and this does still give us a 0. So for all these, you need to set this. So this factor is, we're going to set that one equal to 0, and that one's going to give us a 0 of 0. All right, now because it is squared, it's going to give us 2 zeros at that point. So we have a multiplicity of 2. And then this one is a +4. So that gives us a 0 of -4, and that just has a multiplicity of 1. And the x -1 gives us a 0 of +1. And that has a multiplicity of 1. And again, we're going to add all those up. 2, 3, 4. That's a 4. That's a 4. Everything agrees, and we're good to go. Now, the y-intercept is going to be 0 something. This one, just find f of 0. And if you notice, if you plug in here, 0 to the 4th is 0, 0 cubed is 0, times 3 is 0. This one also gives us a 0. So what happens is you plug the 0 in, and it gives you a 0. Now we've talked about this before, that if we did get a 0 of 0, which is here, notice that not only is it on the x-axis as a 0, but it also intersects the y-axis, so that makes it a y-intercept as well. All right, so let's plot these other zeros. We have 1 as a -4, 1, 2, 3, 4, which is right here. And we have a 1, which is right there. All right, now let's say this is an x4th, so this is similar to the last problem where we're going to be up here and up here. Okay, so it's going to be that end behavior. And we need some additional points. All right, so we have some easy ones here. We have some more difficult ones. So I see 3 points here in between these two zeros, and I think I think we can do them all. So we have a -1, -2, -3. And then it looks like the difficult one, we have a 0 of 0 and 1, and we're going to have to find something in between here. So it looks like we're going to have to put in a half, or 0.5. And then that one I'm not going to do synthetically. We're just going to have to plug that one in. All right, so I had a bit of an interruption there, so let's see what was going on. All right, so we're plugging in these values. Now I'm going to go synthetically with the integers, and then the decimal here I'm going to just plug in. All right, so when we put out these numbers synthetically, we have to fill in for the zeros that are missing. So the x to the 4th is a 1, the x cubed is a 3, the x squared is a -4, and then the x term is a 0, and the constant term is also a 0. All right, oh, that was a bad line, whatever. All right, so let's try -1. So drop it down, -1, 2, -2, -6, and then 6, 6, -6, -6. All right, so I'm going to put this here temporarily, just double check everything. And all right, have a little battery. All right, let's get rid of that little guy. All right, so it seems now it's kind of sketching a little bit here, see if things made sense. So it looks like it comes down from here, it passes through, and it looks like between these two zeros, everything should be negative down here. Then it's going to come up and hit the 0 at 0. Because that 0 is a multiplicity of 2, it's going to bounce. So I'm going to put a B right there. And when it bounces, it's going to come back down. So it looks like all these are going to be negative. So all these should be negative. And that would make sense if all of those are negative. And then after it bounces down, it's going to hit this back up and come through. So that would make sense as well. So let's run these other problems out. And you should be practicing this. If you're having any trouble, and if you're not quite sure what this synthetic stuff is about, you should be practicing every single one of these just so you can do it and not just watching me. Okay, 1, -2, 1, -2. And this one looks like it's going to get the same thing here, maybe. No, maybe not. All right, let's see, -6. Now it's that. So 12, 12. Ooh, -24. 0. All right. Oh, negative. I didn't mean 0. That's a big eraser. And -24. Well, Well, I have to go down to negative 24. So one thing I could do here is right away, I could just call these, I can go down by 2. So let's say negative 2, negative 4, negative 6, negative 8, negative 10, 2, 4, 6, 8, 10. And even this may not hit it, but at least I didn't go down by ones. It'd be pretty far down. 14, 16, 18, 20, and then right about here, maybe 22, right about here. So we're going to be down here somewhere. That's okay. So negative 2 is negative 24. And hopefully negative 3 is not such a large negative number. Negative. And again, 1, 3, negative 4, 0, 0. Okay. Oh my goodness. All right. All right, so that's way down there. All right, so I kind of got ahead of myself, I guess. I had no idea that was going to happen. That's kind of interesting. Well, that's way down there. We'll do the best we can with that one. All right. Well, you know what? By doing the best we can, let's just do the best we can. Let's get rid of these. You know what? Sometimes we just gotta fix stuff. So we gotta get down to a 36. So I have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I got it to a 36. So even going by 4s, maybe even. So I'll put the negatives in later, but 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. So all these are negative. Of course. All right, let's just plot those. So negative 1 is negative 6, which is about here, because it's between 4 and 8. Negative 2 is 24, so that would be here. And negative 3 is 36, which is here. All right, so that's actually a little lopsided there, but that's okay. And we still have to plug in 0.5. All right, so with that one then, I'm just going to plug this into the calculator. So f of 0.5, and that's going to be 0.5 to the 4th power, which would be like 1/16 plus 3 times 0.5 cubed minus 4 times 0.5 squared. All right, I had to pop that in my calculator, and I'm getting that that is negative 0.5625. Let's round that to negative 0.56, because we're never going to be able to graph those small increments of hundreds and thousands. All right, so let's plot that. Now I'm going to plot that in a different color so you can see where that is. It's a little tricky over here. There's a lot of junk. So we're going to 1/2, and that's just a little more than 0.5. So I'm going to guess it's right about here. There we go. We just got to get as close as we can. That's pretty good. And now we're ready to graph. So this is going to come down pretty steep, jump down to here. Now we're still going to try to make this loopy right here. All right. Let's do the best I can with this tablet. Come down. See, there's my wiggle. I can't draw very straight with it. Come up. It comes up through here. I'm doing the best I can. It bounces off the 0. comes down to that 0.56, loops back up. And this side is not going to be quite as steep as the other for a while because of the direction it came from. Here we go. There we go. Next. Okay, just like the last one, I'm always looking for a GCF. And the thing that really jumps out at me on this one is that there is a negative out in front. If you recall, on Friday, if you were here, there were two problems I put on the board. One had a GCF, one had a negative out in front. And for any factoring at all, even if you have an x squared, if there's a negative out in front, you got to get rid of that. We got to pull that right out. So we have a large polynomial here, so I'm going to move that over a little bit. Let's create some sort of factor box. Hopefully I can fit everything in. All right, so the first step is I'm going to pull that negative. Now you can pull a -1 out or just pull the negative sign. And then that's going to cause the signs to change. So I have a positive x to the fourth plus 2x cubed minus 4x squared minus 2x plus 3. Let's just make sure everything changed. Negative the plus, plus the minus, negative the plus, -2 plus. Okay, that one looks okay. And then that negative sign is going to stick with us the whole way down. It looks like I'm going to have this many more lines. And we're going to look like this next. All right, so let's write some of these numbers down. Let's see. Now we're not going to write these down. Now that we pulled the negative out, we're going to put these numbers in. A 1, 2, -4, and so on. 1, 2, -4, -2, and a 3. All right, let's try 1. Let's drop it down. 1 times 1 is 1. Go to 3, 3, -1, -1, -3, -3, 0. All right, we got a hit on the first one, which works out nicely. All right, because that is a 1, then we turn this into an x minus 1 factor. And then the other factor is x cubed. That's a 3. Plus 3x squared minus x minus 3. And then I'm going to drop down the x minus 1. And then I'm going to look for another factor. All right, because 1 went in, I'm going to try 1 again. Now, you could rewrite all these numbers. I like to use them right there because they're already written. Now, don't keep going back into the original function. We're not going back into the original each time. You're going into this new function. So now we're going into 1, 3, -1, and -3, which is already right here. So I'm going to try 1 again. 1. All right, 1 times 1 is 1. We get a 4. And this might work. Let's see, we get a 4. We get a 3. Yep. All right, good. Perfect. First 2 shots, we get 2 good answers. And this one's going pretty well. So this one is also an x minus 1. And then the other factor comes right from here. Remember, this is our r, c, x, and x squared. And that's why I kind of don't write it under this one usually, because then I can reuse those numbers without the letters underneath there. So this is x squared plus 4x plus 3. I'm going to drop down all the previous factors. All right, where were we? Another interruption. All right, so I'm bringing down these other factors. X minus 1, the other x minus 1. And then this is our quadratic, so that should be easy to factor. And we have a plus 3 and a plus 1. All right, so here's all the lines for the zeros again. So we have we have two ones, so there's a 0 of 1 with multiplicity of 2, because there's two of them. We have a negative 3, and we have a negative 1. And both of these are multiplicity of 1. And we add those up. 2, 3, 4. We get a 4. There's a 4. There's a 4. We're good to go. Now, this one, because it's an x to the fourth and a negative out in front, we're looking at this end behavior, which is down here and here. All right, so a multiplicity of the 2 is a 1. So that's going to be a bounce right there. The negative 3, 1, 2, 3. Oh, I just put that in the wrong spot. Let's get rid of that. Oops. I wasn't supposed to erase all that. Sorry, a positive 1, which is right here. Let's put that back. All right. And then the negative 3, 1, 2, 3, which is right here. Oh, we do have a negative 1. I could have left it there. Not playing that well. And there we go. All right, the y-intercept then is 0 something. After plugging in zeros into all these previous terms, you get a negative 3 right there. 1, 2, 3. Right there. And let's make some additional points. In class, I usually put the 0 right there with the negative 3. You can put that there if you want. Just remember that that's the y-intercept. And then I think we can get away with this if, let's see, we just choose a negative 2. I think that will be sufficient. Now, let's just double check what kind of number that should give us. So if we come up here and looks like at negative 3, because this is a multiplicity of 1, we're going to pass through. So this looks like a pass through, and it's going to come up here and be positive and back down to the 1, which is going to, oh, that's the negative 1, which passes through. That almost didn't make sense there. I keep messing that point up. So it's going to come up, it's going to come down, it's going to pass through, it's going to come down here to our 0, and then it's going to come up to 1, and now it's going to bounce. Perfect. Okay, it seems like it makes sense. And then it's going to head down that way. We can probably just start sketching that right there. That's probably going to be about where we would sketch it anyway. All right, so since negative 2 seems to be up here somewhere, that means when we plug that in, it better give us some kind of positive number. And if that's that happens, then I'm good to go. We're ready to graph. So let's plug that in. Now, you have to go back into the original. You can't forget about this negative. This would be a huge mistake. If we forget the negative, it's not going to graph correctly. Even though here, I was factoring into here. It's because we already factored out the negative. But you have to go back into the original. You can plug in here, 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 and here if you want. Everywhere x is, but you still have to consider that. All right, so now we're going into negative 1. Negative 2, 4, 2, and negative 3. All right, that seems good, and we're going to go into that with a negative 2. All right, drop down, multiply, add, multiply, add, multiply, add, multiply, add. All right, so it looks like we have a 9. That's positive, which is good. So even if I made a mistake there somewhere, it seems like the number appeared where it should be, so I'm good with that. We can double check it if we want, but it seems like it is where it should be. So 1, 2, 3, 4, 5, 9, right about here. Okay, seems like it's okay. So even this little angle I have right here It needs to be a little steeper because I have to get all the way up here. Alright, let's see what I can do. It's going to be a little wiggly. Okay. And we're going to come down here. Oh, I'm not liking that too much. And if I had paper pencil, I would fix this a little better. All right, there we go. That's it. Hope that helped. Be prepared tomorrow to finish up those problems that you started on Friday. All right, if you have any questions or see any errors that I did anywhere on this video, please let me know. All right, have a great day. See you tomorrow.